So we finished up with prophase last class. Let me just kind of cover that a little bit. What do you need to know when you're looking at it in the microscope in a little bit of time? You have to look for chromosomes, condensed or coiled or thicker chromatids. So you're going to see normal cells, right? Normal cell would just look like, a happy-go-lucky. Let's see. So let's do that. Let's do this. So you'd have a normal cell. And you have the nucleus and the nucleolus. How's that going to look different in prophase? What would happen? Here's my cell, then what? Here's my nucleus, and then what? What are you going to see? What's it going to look like differently? The nuclear membrane and nucleus starts to disappear. The centrioles and animal cells begin to move to opposite sides. Spindle fibers that are microtubules attach and form. So what am I going to see under a microscope? What am I going to see? What's that? Look at it. What am I doing? Start breaking down. Then what? All right, the membrane disappears, and then what? What am I going to see inside? Because it just looks like this. Remember those like big like lines, right? So you're going to see like a little bit of this, a little bit of that. I'm going to go ahead and throw some other colors in there. A little bit of this, a little bit of that, a little bit of that. You're going to start seeing those darkened lines. Okay? I started breaking down the nuclear membrane. The nucleus is going to disappear. Oh, what did the centrioles look like? What do those look like? All right, they're the guys that are going to start moving. I'm going to make them like an L shape. Right? So they're going to start moving to the opposite sides. And then we have what other thing? What other thing are we going to have? What other thing are we going to have? What else? What else? Yes? All right, so we're going to have some spindle fibers. We're going to have them start coming off. All right, so they're going to start forming in there. Prophase. Yeah? Yes? Okay. It's a really good piece of art right there. I know you like it. Okay. Now, so we have G2 of interphase. And then prophase. So what are the three steps that we have? We have in interphase. What do we have? G1, G1, S, G2. So right before we get to G2, so we're going to start to move away. Here's my lovely handy dandy centrioles. I don't think this clearly does justice to my picture. I think definitely mine was better. But G2 of interphase, the centrosomes. All right, centriole pairs. Chromatin. What is chromatin? Chromatin? What is it? What is it? What is it? What is it? Yes.
DNA and protein complex.
Oh my gosh, I told you had to know that. Come on, grass. All right. DNA and protein complex. What are the proteins we're talking about? What are the proteins we're talking about? What proteins? Rutabaga. Histone proteins. All right, remember we have the histone. The DNA is wrapped around the histone. All right, what does the aster do? I told you last class, what does it do? What does it do? Maybe I didn't tell you. What does it do? What do you think? Not creating the spindle fibers because those come from the microtubules, but you're warm. All right, so it gives the spindle fiber something to connect to. All right, it also is going to anchor to the cell membrane so it can help yank it apart. The anchor there to the spindle fibers, the other side is going to anchor to the cell membrane. Okay, so we got those centromeres in there. Oh, what's a whoa, 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 whoa? What's the centromere? Look at it. What is that? There's one. There's one there. There's one there. What is that? Yes.
It's where the two sister chromatids are joined together.
Yes. Sister. I don't know really what happened right there. That was weird. All right, sister chromatids joined together. Okay, good. Okay, remember, you gotta be an expert. Don't be a bump on a log here. Sister chromatids linked. Okay, good. Nucleolus. Okay, so we still see we have a little nucleolus here. Mark that down where you see a lot of the concentration. Just mark it so you see it on your page. Nuclear envelope. We all know where that is. What comes out of the nuclear envelope based on last class's discussion? What comes out of it? What comes through a nuclear pore? mRNA. Thank you. Through the nuclear pore, we know that we're going to get mRNA. Plasma membrane, you should be good on that. Chromosomes consisting of 2 sister chromatids. Okay, good. Next, metaphase. What did we say about metaphase? What are we going to say about meta? Yes. Middle. All right, so we gotta, when we're looking at it on a slide, we gotta find all the stuff in the middle. What are all the stuff in the middle? What's all the stuff? Yes? Okay, so we got our sisters here. All right, so all those things are going to be lined up in the middle along the metaphase plate. This metaphase plate is very similar to what? If you're looking at this as a really big picture, what does it remind you of? What? The equator. All right, kind of like, I always tell this story, you know, when I was a little kid and, you know, all of my friends, we left the playground and, you know, they were riding home their bikes and they were passing me, and I asked them where they're going, and they're going, oh, gotta go see the Kool-Aid Man, the Kool-Aid Man. And I said, no, it's just my mom in a red dress. Equator, no. Sounds like a equator. Okay, so the mitotic spindle is fully formed, anchored by the centrioles at each pole. So the centrioles are anchoring with what? We got our aster in there as well. The chromosomes, which are lined up in the spindle fibers, are now moved to the middle of the cell, like the equator of the Earth. Okay? Any questions on metaphase? You got to know the metaphase plate in the middle. See how my aster is starting to link up here. Technically, these are going to be linked up here in just a minute because they need something to hold on to. They can't just pull stuff apart. They got to anchor onto that plasma membrane. Okay? All right. Next. What's next? Anaphase, you guys. Anaphase. All right. So what do we say? How do we know it looks like anaphase? To me, that looks like an A, anaphase. So when you're looking at it under a microscope here in the next couple minutes, you're going to be looking for the little A's for anaphase. All right, the chromosomes split into sister chromatids, which are pulled towards the pole by the spindle fibers, and the cell membrane becomes oval shaped. All right, so it's just elongating. The cell is elongating now. So instead of being a nice sphere, it's now much more oval. Now I can always do a perfect sphere. I mean, I'm one of those teachers that can do a perfect sphere. So obviously I know it's not a perfect sphere. Not a sphere. Okay, so we're going to pull those apart. Now we're into sister chromatids. So kind of last, on metaphase, we're still technically still chromosomes. And now we're going to be sister chromatids. So they were attaching at the centromere and they're going to pull them apart. So now these technically are sister chromatids. All right, so just make sure you make a note on the other one. They were still technically chromosomes. All right, still technically chromosomes in metaphase until they get pulled apart. Yes? Yes, you can sit here if you want. No? Okay. It's a weird shaped room. It's really big, you know, it's weird. Hey, I don't like this room. It's really long. Okay. Any questions? So now we are good. We have our daughter chromosomes would be a single one here, single one here. All right? Daughter chromosomes, a single side of the sister chromatid. Okay. And what comes next? Telophase. All right, the sister chromatids reach each pole and the spindle begins to disappear. We're now peanut shaped. We have a lovely cleavage furrow right here. So I have a picture on the back that you can look at the cleavage furrow, as Alex is laughing about the cleavage furrow. It looks like a butt, I know. There's a picture. Look at it. It's right below your hand. See the cleavage furrow under a microscope? Yes? All right. I know. All right. So it kind of looks like a buttocks. That's okay. All right. The sister chromatids reach each pole, and the spindle begins to disappear in peanut shape. 2 new nuclear membranes form around each set of chromatids, which unwind to become chromatin. What's a chromatin again? What is that? Chromatin? What is it?
DNA and protein complex.
Okay, I'll say it one more time for the 15th time in 2 days. The DNA and protein complex. All right, what's the protein? Histone. Oh, good. And then we have the nuclear envelope starting to reform. We got all the nucleolus starting to reform. And obviously we know we're going to end up splitting right down the middle here. Telophase for me, T is 2 new cells. All right, 2 new cells. And we're good to go. But I'm not taking it off yet. All right, take a look. Your aster is going to start to disintegrate as well at this point because the spindle fibers are no longer there. All right, and then boom. Where do you think the spindle fibers are going to go? What do you think is going to happen to those? They're going to help construct both the nuclear membrane as well as go back and be microtubules. Okay, so they're going to be 2 new locations on those. Okay. That was the longest part of the notes. Now we have just a couple things to finish up. The difference between plant cell mitosis and animal cell mitosis. All right. Notice I did put everything online, but the portal was broke the other night, so it went on yesterday morning when it got fixed at 10 o'clock. Okay. All right, so we have some wonderful pictures. A cleavage furrow. All right. Kind of looks like a buttocks here. I understand that. So in an animal cell on the left, so this is all animal cell. All right. We're going to have this guy coming right here. Obviously, that's getting stretched out. And then we're going to go ahead and split up into 2 daughter cells. How much DNA material would be in the daughter cell compared to the original cell? All right. If I started with 46 here, okay, let's say my original cell had 46 chromosomes. When I divide, how many would I have? What? 46. All right, they kind of have the same. Because if you keep having it, what's going to happen? You're not going to have any chromosomes or DNA left. So when you create new daughter cells in mitosis equals same number of chromosomes when you started. When you started. All right, you can't just keep having it. We'll talk about meiosis, which will have the numbers, because then when the egg and the sperm go together, you get a full set. These all have to have the same amount of DNA. Okay, the difference in plant cytokinesis. What's cytokinesis? Division of what? Division of cytoplasm. All right, when that divides, you're going to see a vesicles forming the cell plate. All those vesicles are going to be, I see a whole bunch of them here. All right, all these guys are going to start forming what we call a cell plate. There's no cell plate in the animal cell. All right, And then from that cell plate, it's going to split all the wonderful DNA and all the material up after mitosis has occurred. This is after mitosis. After mitosis. Has to form a cell plate. So it has to form a cell plate. From the cell plate that's going to form a new cell wall, and you're going to get two distinct daughter cells. How much DNA is going to be in these two daughter cells? What? The same. All right, so same amount, same number, chrome. I'm just going to put chromosomes, and I know that bothers Noah because he doesn't like the word chromosome for DNA, but that's okay. All right, that's okay. All right. Ready? Ready, Freddie? Yes? Okay. Can you find a cell in each phase? Can you find a cell in each phase? All right, I'm going to go ahead and switch colors while you're thinking. And I need some help. Somebody come on up here. Come on up here, Bruce. Come on down. All right, where you going? No. Circle one. All right, what is it?
Anaphase.
Anaphase. Very good. I'm going to put Anna. All right, who wants to come up? Y'all get to do one. Y'all get to do one. Come on up, Cheyenne. Don't be, hustle. Who's after Cheyenne? Come on. Come on, who's going to be after Cheyenne? Let's go. Y'all get to do one. There's plenty. Let's go. Everybody go. 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 All right, good. Somebody else, go. Grab one. Go. Yes, thank you. We're recording, so you gotta go.
This one's also telophase.
All right, telophase. Put a T in that one and a T in Cheyenne's. Yes, go. Somebody go. Go. There you go, Alex. All the good ones are going to be taken if you wait. They're all going to be taken. You gotta go.
Wait, are we supposed to do the same one?
All right. You can't do the same one as somebody else.
I know, but like
They're running out of space. Come on. All right, what do you got?
cytokinesis.
Okay.
CK.
CK.
going on?
CK.
Raising hands.
Yeah, just go. Fill up your spot. Find one before somebody takes a good one.
Get up, Kyle.
All right, yeah, Mary. Woo! What do we got there? Oh, CK, okay. All right. Okay, Kevin. Woo! Yes.
All right.
This is a cell identification race. You're going to have to do this on a microscope in like 2 minutes. Yes. Yes. Ooh, baby. If that one doesn't work, turn it on. It'll work. Gonna turn it on? Maybe you can only do one at a time. I don't know. Oh, yeah. All right, go ahead. Looking good. All right, nobody wants to claim their own. Say, Matt, chick in the house. Say, chick in the house, buddy. Chick in the house. Say it. Yes. Well, you only do one at a time. There we go. They both try to do it at the same time. All right, little cytokinesis there, good. There's one in the house. You gotta say it. Oh, we got a prophase, finally. All right, you guys look good. Sherwood, thank you. Awesome, good work. Thank you. Noah, you didn't go. Too bad. All right, now you're going to do this on real cells. Can you find a cell in each phase? Raise your hand if you can tell me what this is right here. What's this one right here?
Oh.
Metaphase. Prophase, you're going to see the breaking down. Okay, what about this one? Anaphase. All right. Look at this one's kind of all sloppy. That's going to be Prophase. When it's all sloppy. All right, prophase, anaphase, metaphase. Oh, what about this one right here? Interphase. Interphase. All right, what about this guy right here? There's a cell plate forming. Cytothesis. All right, so you see a cell plate, if you see a little bit in there. What else do I need? Telophase, anaphase, prophase, interphase, telophase. All right, so telophase, you could say
That doesn't count.
telophase there. Where? Here? This? That's prophase. Oh, right here. Here's telophase. Okay, so you're going to be doing that on your own. Okay. All right, we got some of those in there. Prophase. Mitosis and tumors. Real quick. Sometimes cell division continues unchecked and can produce an excess of cells, and that's called a tumor. When uncontrollable cell division is cancer. That's being around cancer sticks and UV radiation and many other things can cause uncontrollable cell division. Tumors can be benign or malignant. What's the difference? What's the difference if something's benign or malignant? Yes?
Isn't it when it's like a malignant tumor, it like can spread or something?
Okay, so which is a bad one? Okay, very good. All right, caused by mutations, environmental factors, or genetic predisposition. All right, so the thing you know is ABCD. All right, you have to know that for IV, ABCD, asymmetry, border irregularity, color, and diameter. More than 1/4 of an inch or 6 millimeters. Okay, so it's uncontrollable cell division is cancer, and you can notice that through many different ways. And looking at the color, the border irregularity, asymmetry, and those are caused by environmental factors most of the time, if not environmental. Now, here's the deal. We didn't have a lot of cancer back when humans started out, because why? There was no, bad drinking water, no pollutants in the sky, no hormones in your milk, all that stuff like that.
What's a cancer?
Hormones in my
What
milk.
is it?
Cigarettes.
A cancer stick? You don't know what a cancer stick is? Somebody tell me what a cancer stick is.
Cigarette.
Cigarette.
Oh, what about a cigar? Same thing?
That is a cancer stick.